In this problem, again, we study a relationship between a direct trigonometric function cosine and an inverse trigonometric function arctangent. There are 4 parts in this problem in which we need to work with these two functions. For example, in the first problem, we're given that theta is some angle between 0 and pi, and the tangent theta equals -2. We need to draw these elements, -2, theta, and cosine theta, in the unit circle. All right. Where is the axis of tangents? The axis of tangents, remember, is a vertical line that passes through the point 1, 0. Let's say this here is -2. Theta is some angle in 0 pi whose tangent equals -2. So let's draw the line joining the origin and this point on the axis of tangents. Of course, there are many angles whose tangent equals -2. We want the angle which is here. That is theta. Note, by the way, that immediately it becomes clear from this picture. It's an interesting fact that's worth noting. That since tangent theta is -2 and theta is in 0 pi, it follows, see the picture, that in fact theta is in pi over 2 pi, i.e. theta is in quadrant 2. That means that theta cannot be arctangent of -2. Theta is not arctangent of -2. Remember, arctangent by definition is between -pi over 2, pi over 2. Theta is outside that range. In fact, this angle here is arctangent of -2. And immediately we see the relationship between them. If we add to arctangent of -2 1/2 revolution, we get theta. We first go by arctangent of -2, that brings us here, and then we make a half revolution in the positive direction, that brings us to theta. Now, where is cosine theta? Cosine theta is this distance, sine distance, of course. In particular, it follows that, note again, that cosine theta is negative, theta is in quadrant 2. All right, so that finishes part 1 of this problem. Now, in part 2, we need to find cosine theta. And even though theta is not arctangent of negative 2, theta is related to arctangent of negative 2. So we may want to recall any of the identities that involve both cosine and tangent. So by the Pythagorean identity, sine squared plus cosine squared is 1. Now, assuming that cosine is not 0, this implies that sine squared over cosine squared plus cosine squared over cosine squared equals 1 over cosine squared. So I took this identity and simply divided through by cosine squared, i.e. sine squared over cosine squared is of course tangent squared, cosine over cosine is 1, and 1 over cosine squared stays as is. Now, we are given that tangent theta is negative 2. So in our case, if I use this formula for theta, tangent squared of theta plus 1 equals 1 over cosine squared theta. Therefore, cosine squared theta equals 1 over 1 plus tangent squared theta, and that is 1 over 1 plus. Again, tangent theta is known to be negative 2. So if I use this information here, I get that cosine squared theta equals 1/5. Now, recalling that cosine theta is negative, remember we explained that theta is an angle in quadrant 2, which means cosine theta is negative. This immediately implies that cosine theta is negative root of 1/5, which is negative root 5 over 5. That finishes part 2. Now, in part 3, we need to find cosine of arctangent of negative 2. You have to be absolutely careful here. It might be tempting to say that cosine of arctangent of -2 is the same as cosine theta, but it's definitely wrong, because if you look at the picture, here is theta, it's in quadrant 2, and arctangent of -2 is in quadrant 4. Of course, these points are diametrically opposite, and so their sines and cosines are equal by absolute value and different by sign. So cosine of arctangent of -2 will be negative of cosine theta. This time it's positive root 5 over 5. And now part 4. For any arbitrary real number y, find cosine of arctangent y. More specifically, find an expression of this quantity that doesn't use any trigonometric functions. We again use this identity that we used before, namely the identity that tangent squared plus 1 equals 1 over cosine squared. This, of course, is only true whenever x is not equal to pi over 2 plus pi n, where n is an integer. For otherwise, cosine turns 0, and cosine is in the denominator, so we can do that. Now, if we, instead of x, write here arctangent y, so let x in this formula be arctangent y. Remember again, arctangent y is a negative pi over 2 by the very definition of arctangent. So this identity gives tangent squared of arctangent y plus 1 equals 1 over cosine squared of arctangent y. That is, cosine squared of arctangent y equals 1 over tangent squared of arctangent y plus 1. Now, of course, tangent of arctangent y is simply y, so tangent squared of arctangent y is y squared. I can rewrite this as tangent of arctangent y squared plus 1 equals y over y squared plus 1. So we have obtained the fact that cosine squared y equals 1 over y squared. Now, before we take the square root, we again recall that arctangent y, that was supposed to be, of course, arctangent y. Arctangent y is between negative pi over 2 and pi over 2, by the very definition of arctangent. So that's either quadrant 1 or quadrant 4. Cosine of that is positive. And therefore, when we take the square root, we should take the positive sign. Technically, it's plus minus, but we should take the plus sign because cosine of arctangent is positive. So that finishes part 4 of this problem. Again, the most important thing in this problem was to realize that theta is not really arctangent of -2, even though tangent theta is -2. They are different by a half revolution. So this problem is now finished.